All right, geometry topic 2 review on parallel and perpendicular lines. So yes, there will be several questions involving these on the state test. Now, it won't be as simple as maybe on like your 8th grade OST where they did talk about like these type of angle pairs, right? But again, parallel lines, right? You do have 4 special angle pairs. You have the same side interior, which are supplementary, add to 180, and then you have your alternate interior angles, your corresponding angles, and your alternate exterior angles that are congruent, right? So again, the alternate interior angles and the corresponding angles to me are the ones that are most prevalent, okay? Now, these you will see in proofs for sure, okay? Now, along with these 4 angle pairs, you also have to remember 2 other angle pairs that don't require parallel lines. The first pair are vertical angles, right? So remember that vertical angles are created when 2 lines intersect like this. Okay, so in this picture, angle 1 and 2 are vertical angles. They're going to be congruent. So there's vertical angles. Okay, you also have to be cognizant of linear pairs. Linear pairs are also formed when lines intersect, but they are the adjacent angles. So say angle 1 and say angle 3. So now angle 1 and angle 3 are a linear pair. They're going to be supplementary. So angle 1 plus angle 3 equals 180. Right? And again, these do not require parallel lines like you see up here. So be aware of those 2 other angle pair relationships. Next, you have lesson 2.2 on proving lines parallel. Again, you might see something like this. These are just the converses from up above, converses from 2.1. Again, you're just trying to prove the lines parallel. Not a big deal here. 2.3. So yes, you will see, I believe, the triangle angle sum theorem, the fact that the 3 angles add up to 180, right? This is an important idea. Sometimes you have to prove this idea. It's actually a state standard. So in the proof, it is one specific proof. You just draw a parallel line up here. So this line parallel to that line, okay? And you typically have angles 1, 2, and 3 up here, and then they have angles A and B down here, right? So because these lines are parallel, angle 1 and angle A are congruent. And then angle 3 and angle B are congruent. And these 3 angles up here, angle 1, 2, and 3, they are supplementary. So they add up to 180. So then you can substitute A and B, and then angle 2 is just the 3rd angle in that triangle. And that's how this formula comes to be. Okay, so again, you might see that proof. And then last but not least is the slopes of parallel and perpendicular lines. And this is a huge idea, right? The state test loves when it can combine geometry and algebra. This is one of the ways, right? So we know that parallel lines have the same slope, right? So say the slope of line J would be, let's say, 2/3. Well, then the slope of line K would also be 2/3, right? Up here, perpendicular lines have slopes that have a product of -1. That also means they have opposite reciprocal slopes. So say that the slope of line M that's going to be a negative slope. Let's say that's -3/4. Well, then the slope of line N is the opposite reciprocal of that, which would be +4/3. Okay. Recall the point slope form. Y minus y1 equals m parentheses x minus x1. Remember that in this formula, you need to have a point, x1, y1, and you have to have a slope. And what you do is you plug in your y1, your m, and your x1. And you can simplify this into slope-intercept form, or I think they should accept the point-slope form if that's all you do. Okay. And then again, typically what happens in these problems is they give you a point, and then they'll give you an equation like y equals mx plus b. You need to take the slope from that equation, either use it if it's parallel, or take the opposite reciprocal if it's perpendicular, and then use the point they give you and plug it into point-slope form. You can also use Desmos, right? So don't forget the graphing calculator, right? So if you have to find the equation of a line, you can always graph the original line, graph the points, and try to piece it together that way too. So make sure you use your tools. Okay, now there's topic 2.